Hello, this is Gary Cody. Uh, I'm the manufacturing, engineering, technology, and the trades state leader here for the Innovative Curriculum Resource Project. And today what I was going to talk about is a tool for teaching. And this is a tool. Yes, it is for electronics, but please don't start shutting down your screens right now or walking away. But if you're doing computer programming in your classroom, this tool has a great simulator for doing that. And the programming language is C. So let's take a look at that here. What I want to do is I want to get to my, I'm going to go just to Google. And I always like doing this, going from Google. And what I'm going to do is Google tinkerCAD. And just tinker and CAD. And it gets me to this website here. Now I have a sign on for it, so it automatically signs me into it. There is two parts to this tinkerCAD. If you notice in the upper left-hand corner, there's Autodesk. And this is a site that Autodesk is associated with. It. There is actually a CAD program in here, so you can do drawings with it. The one I'm interested in is the circuits. And I'm going to pull up circuits right here. And we have a bunch of circuits that I've worked on. I think what I'll do is I'm going to go over and grab this one right here. And if you have an electronics teacher in your building, or even the physics teacher, for example, physics, they teach series and parallel circuits. This is a great tool here. You may want to refer them. This video is in our library on the website, www.ilcte.org. It's on our YouTube library, and it's called tinkerCAD. But what's kind of neat is you can build these circuits up. And I've got a series circuit right here. Oh, the other thing this is key, besides the electronics, besides the physics teacher, automotive teaches series and parallel circuits. I know I used breadboarding, and I know the teacher that was teaching it alongside me, he also used breadboarding and talked to the kids, because in the autos curriculum, they talk about series and parallel circuits and using voltmeters and that. So what's kind of nice, I've got resistors on here. And if I go over here and change this, they got a tremendous amount of components here that you can put on here and do simulations with. And it's really great. They even have regular old incandescent light bulbs. Oops, I must have passed them somewhere. This is what I'm going to talk about here in a few minutes is Arduino, and that's in C programming. So like I said, don't go away if you've got programming in your curriculum here. So, all right, I'm going to start simulation here. And what I've got is I've got a meter here set up for current. It's got a little A up there for amps, and it's in series. So the series current here is 10 milliamps. And then I've got a voltmeter. I'm supplying 6 volts to the circuit, but I've got a voltmeter connected across this resistor, and that resistor's got 2 volts across it. So like I said, it's a great tool. I've got a parallel circuit down here. Works just as well for parallel circuits. And if you notice, I got minus on here. Well, I could hook my amp meter up with polarity change and get the plus. And it's even got an ohm meter. And they do have components. Here's a potentiometer that you can vary the resistance on it. So you can go from 0 ohms. If we go all the way over to the other side there, about 250 K ohms. So it's great as students actually, physically can play with meters. They can hook it up, and the circuits are very good for calculations. If you use Ohm's law, they're very good for that application. All right, let's take a look. I want to look at, I gotta go back out, and I want to get my Arduino here. There we go. And like I said, if you're doing programming or if you've got another tech ed teacher in your building that does programming, tell them, hey, here's a nice little tool. It's C programming. Actually, it's object oriented, so it's C/C++ that you can program into this little microprocessor. This is a, if you're not familiar with this microprocessor, oh my goodness, there's a ton of programs and applications out there. Once again, you can hook up any kind of hardware you want with these. I just have a little LED here. We can take a look at my code. Very simple little program I've got in here. I blink the light on and off, 1 second on, 1 second off. So let me start up the simulation here. And as you see, the LED is blinking on and off. Does a fantastic job. Great job. The other thing is, just like if you work with these microprocessors and you use the regular development software with it, that software, as long as you've got your USB cable plugged in, it's going to give you a message back. So they have a serial monitor. And let's see if I can get this opened up here a little bit. But anyway, I've got some little debug. You can put debug messages in there, debug your program. I've got mine going here, LED on, LED off, LED on, LED off. So it goes along and tells me what the program's going. Once again, fabulous. I had this tool. I have a cabin up in Wisconsin that's got electric water heater, and I kind of want to know how long the electric water heater was running for. And so I put together a little simulation. Actually, I guess I can show it to you here. Yeah, this one right here. I put this little circuit together. I bought a little ferrite bead that you can snap around the AC power line. It'll give you actually an AC signal. And so I did all the testing of the software. I did the simulation of the thing that snaps around the AC power line. Let me just start the simulation here. And it's just a regular AC circuit right there. So I got an oscilloscope on it and I debugged everything, wrote everything in here, debugged it, took it downstairs in my house here to test it first. Sure enough, worked. So like I said, this is a fantastic tool. So please, please, please share that with your tech ed teachers. And if you got any questions, you know, you can always email me at grcody@ilstu.edu. So, all right. Thank you.